Hello everyone. In this video we will learn about the Cramers Rule and its application to find out the solution of linear equations in two or more variables. To understand the Cramers Rule, we take one system of linear equations in two variables. The first equation is a1x plus b1y equal to c1 and the second one is a2x plus b2y equal to c2. By transposing the constant terms, we convert them into the standard forms. The first one will be a1x plus b1y minus c1 equal to 0 and the second is a2x plus b2y minus c2 equal to 0. We can find out the solution of this system of equation by using cross multiplication method. We have already learnt cross multiplication method to find the solution of linear equations in the video solution of pair of linear equations in two variables. So here we go, we will find x upon b1 into minus c2, that is b1 c2 with negative sign, and minus b2 into minus c1, that is plus b2 into c1, equal to y upon, the same way this is minus a2 into c1 plus a1 into c2, equal to 1 upon a1 b2 minus a2 b1. These denominators can be represented as the determinants. And we find here this is x upon the determinant c1, c2, b1, b2. You can see here this is c1 into b2 minus b1 into c2. Similarly, this is a1, a2, c1, c2 and the one it is a1, a2, b1, b2. We can represent this particular determinant as delta. This one is delta x or delta 1 and this one we can represent as delta y or delta 2. So we can represent this as x upon delta x equal to y upon delta y equal to 1 upon delta. And from here we get the value of x will be delta x upon delta or delta 1 upon delta, and that of y will be delta y upon delta or delta 2 upon delta. This is known as the Cramers Rule and this can be used as a formula to find out the values of x and y from this system of equations. Here we have to remember one thing, that to obtain delta x or delta 1, what we do? We replace the first column from this delta by the coefficients of x, that is c1, c2. And to get delta y, we replace the second column, that is the coefficients of y in delta, by the constant terms, that is c1 and c2. Similarly, for the system of linear equations in three variables, a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3, we get delta, that is the coefficients of x, y and z we write in the columns a1, a2, a3, b1, b2, b3 and c1, c2, c3. To find delta x, or we say delta 1, we will replace the first column by the constants, that is the coefficients of x we will be replacing by the constant terms. So it will be d1, d2, d3, b1, b2, b3 and c1, c2, c3. To obtain delta y, or we say delta 2, we will replace the second column, that is the coefficients of y, by the constant terms. So this comes as a1, a2, a3, d1, d2, d3 and c1, c2, c3. To get delta z, or we say delta 3, we will replace the third column, that is the coefficients of z, with the constant terms. So we get here a1, a2, a3, b1, b2, b3 and d1, d2, d3. After obtaining all these four determinants, We can find the value of x as delta x upon delta, y by delta y upon delta, z by delta z upon delta. So we can find the solution of linear equations in 3 variables also by using the Cramers rule. After getting the solutions for 2 variables as x is equal to delta x upon delta, y is equal to delta y upon delta, and for 3 variables x is equal to delta x upon delta, y equal to delta y upon delta, and z equal to delta z upon delta. What we see? Delta is coming in the denominators, so this will play a vital role, an important role. How it is? See the conditions now. In first case we can have that delta is not equal to 0. If delta is not equal to 0, then certainly we will have a unique solution and the system will be consistent. So we can say then system is consistent with unique solution. In the second case we can have if delta is equal to 0, then we can have 2 different cases. If delta is 0 and delta x, delta y and delta z, at least one of them is non-zero. At least one of them is non-zero. Then what will happen? If it is non-zero, then delta x upon 0 will say that either x does not exist or y does not exist or z does not exist, and that is why we say that there is no solution. There is no solution. And if there is no solution, we say the system is inconsistent. Now the second case when delta is 0 may be if delta x is equal to delta y is equal to delta z is equal to 0. Means all delta x, delta y and delta z are 0. Then what will happen? Can we say that delta x is equal to x into delta, delta y is equal to y into delta, and delta z is equal to z into delta will be satisfied by all the values of x, y and z or not? Will satisfy for all x, y and z. Let them be having any value. Then what we can say? It will have infinitely many solutions. So we say infinitely many solutions. It means the system is consistent. So these are the conditions we have to remember to find the solution of any of the system of equations by using Cramers rule. We discussed now some examples to understand the concept more clearly, and the first example we are taking, that is in 2 variables. 2x plus 3y equal to 3 is the first equation, and x minus 2y equal to 5 is the second equation. Here delta will be the determinant of coefficients of x and y, and here it is 2, 1 for x. For y, 3 minus 2. If we find the value of this determinant, that will be 2 into minus 2 minus 1 into 3. That is minus 4 minus 3, or we can say minus 7. It is not equal to 0. And if delta is not equal to 0, we can say it will be consistent with unique solution. Therefore, the system is consistent with unique solution. Now we can go for delta x, replacing the first column by the constants, and that we are finding is 3 and 5. So 3, 5, 3 minus 2, this is delta x. Finding the value 3 into minus 2 minus 5 into 3, this is minus 6 minus 15, or we can say minus 21. Delta y, replacing the second column by the constants. So it will be 2, 1, 3, 5. Calculating the value 2 into 5 minus 1 into 3, 10 minus 3, that is 7. And then we can find the values of x and y. X is delta x upon delta. Delta x here is minus 21. Delta is minus 7. So this comes as 3. Y, that is delta y upon delta. Delta y here is 7. Delta is minus 7. So this is minus 1. And hence we are getting the values of x as 3 and y as minus 1. This is the answer to the problem. The next example we discuss on 3 variables. And the equations are x plus y plus z equal to 2. 2x minus 3y plus z equal to 13. And 3x minus y minus z equal to 10. Here we can see delta will be the coefficient of x here 1, 2, 3. Coefficients of y in the second column 1, minus 3, minus 1, and the coefficients of z 1, 1 and minus 1 in the third column. And we know how to find out the value of the determinant. When you calculate the value of this will come as 16. Now delta x, or we say delta 1. Here, as I told you, that we will replace the first column by the constants. That is, the coefficients of x will be replaced by the constant terms. And here we get here, that is 2, 13 and 10. These are same 1, minus 3, minus 1, 1, 1, minus 1. And when we calculate the value of this, the value will come as 48. Then delta y, we will replace the second column by the constant terms. And that will be here 2, 13, 10. The first and third columns will be same 1, 2, 3, 1, 1, minus 1. And the value of this will come as minus 32. Delta z. Here we will replace the third column, the coefficients of z by the constant terms. So we will find it here 1, 2, 3, 1 minus 3 minus 1. And here this will be 2, 13 and 10. And when we calculate the value of this, the value will come as 16. We have seen that delta is not equal to 0. And if delta is not equal to 0 and all these are also non-zero, we are finding it will have a consistent and unique solution. So we say the system is consistent with unique solution. And the unique solution here is x equal to delta x upon delta. Here it comes as 48 upon 16, which is 3. Y equal to delta y upon delta, and here it comes as minus 32 upon 16, that is minus 2. And z comes as delta z upon delta, that is 16 upon 16 is equal to 1. And hence we get the solution as x is equal to 3, y equal to minus 2, z equal to 1. This is the answer to this problem. The next example of 3 variables is x minus 3y minus 8z equal to minus 10 is the first equation. 3x plus y minus 4z equal to 0 is the second equation. And 2x plus 5y plus 6z equal to 13 is the third equation. Delta, determinant of the coefficients. Here we find it is 1, 3, 2, minus 3, 1, 5 and minus 8, minus 4 and 6. And when we calculate the value of the determinant is coming as 0. And if delta is 0, we know the system may be consistent or inconsistent. Now we find delta x. We replace the first column by the constants. So it will be minus 10, 0, 13. And here it is minus 3, 1, 5, minus 8, minus 4, 6. When you calculate the value of this, that will be coming as 0. Delta y. We will replace the second column by the constants. That will be minus 10, 0, 13. The first and third columns will remain same. It is 1, 3, 2, minus 8, minus 4, 6. And when we calculate the value of this also comes as 0. Then we go for delta z. Here we replace the third column by the constant terms, and here it comes as minus 10, 0, 13. The first and second columns will remain same. That is 1, 3, 2, minus 3, 1, 5. And the value of this also when we calculate is coming 0. And if the value of all the determinants is 0, then we say the system is consistent with infinitely many solutions. So we say therefore the system is consistent with infinitely many solutions. And for that we know that we take any of x, y or z as k, an arbitrary constant. So we are taking here z equal to k. Then we find the equations will be x minus 3y equal to minus 10 plus 8k. This will be fourth equation from first. From the second equation we get 3x plus y equal to 4k. This is the fifth equation. And from the third equation we get 2x plus 5y equal to 13 minus 6k. This is the sixth equation. Solving these equations, we get the values as x is equal to 2k minus 1, y equal to 3 minus 2k and z equal to k. This is the answer to the problem, and like this we can find out infinitely many solutions. If any one of these three determinants is non-zero, then we say that the system is inconsistent with no solutions. Now we discuss about the solution of homogeneous linear equations by using Cramers rule. See, we have already learnt about homogeneous linear equations. What are those? We say that the homogeneous linear equations are the equations in which the constant terms are 0. And here we find a system of equations. This is a1x plus b1y plus c1z equal to 0. a2x plus b2y plus c2z equal to 0 and a3x plus b3y plus c3z equal to 0. To find out the solution of such problems by using Cramer's rule, we have to find delta first. The coefficients of x, y and z in the columns. This is a1, a2, a3, b1, b2, b3 and c1, c2, c3. Now the main thing depends on the value of delta only, if delta is 0 or it is non-zero, because we know that delta x in such case will be 0, 0, 0, b1, b2, b3, c1, c2, c3, and the value of this will be 0 because all the elements of first column are 0. Similarly, we will find that delta y and delta z also will be equal to 0. Now we discuss about the two cases when delta is 0 and when it is non-zero. So the case first we take when delta is non-zero. If delta is non-zero and we know that all these delta x, delta y, delta z are 0. So certainly we will have x equal to y equal to z equal to 0. And we know that this solution is known as trivial solution. It means if delta is not equal to 0, we can say that the system will have trivial solution. Case 2, if delta is equal to 0. If delta is 0, then certainly this delta x, delta y, delta z are 0. So what we can say? That the system will be consistent with infinitely many solutions. So we can say system is consistent with infinitely many solutions. It means there is no case in case of homogeneous linear equations where there will be no solution, the system will be inconsistent. The system is always consistent. The only thing is either it will have a trivial solution or it will have infinitely many solutions. You all must be finding these videos useful for you. So if you have not subscribed the channel so far, subscribe it now to get more interesting and conceptual videos on different topics of mathematics. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.